Assalamualaikum and Hal. We are from CBCS 248 Partner 1. We will present our group project, which is an application of line integral. Before we start, may I introduce my team members, Patricia binti Syarul Anwar, Nur Hazira binti Nur Zakwan, and Siti Nur Hamizah binti Hamzah.
A line integral was invented in the early 19th century to solve problems involving fluid flows, magnetism, electricity, and forces. Line integral is like a single integral, except that instead of integrating over an interval a and b, we integrate over a curve c. Just as for an ordinary single interval, we can interpret the line integral of a positive function as an area. In fact, if fxy is greater and equal to 0, integrate fxy ds over a curve c represents the area of one side of the fence or curtain, whose base is c and whose height above the point s, x and y is fxy. Figure 1 shows the line integral over a scalar field. The line integral for a function of two variables, which is x and y, along a curve c is given as integrate fxy multiply with ds, where basically ds is the differential arc length along the curve c. And the formula for ds is square root of dx dt square plus dy dt square, ranging from a to b. Next, we move to the line integral for a function of three variables, which is x, y, and z. Along a curve c is given as integrate fx, y, and z multiply with ds. This table shows some basic curves that we will need to know to do, as well as limits on the parameter if they are required. For ellipse, the x is a cos t for both counterclockwise and clockwise, but for counterclockwise, y is positive b sin t, and clockwise is y equals to negative b sin t. The t ranging from 0 to 2 pi. Basically same as circle, but for circle, the x is r cos t, and y for counterclockwise is positive r sin t. For the clockwise, y equals to negative r sin t. The t ranging from 0 to 2 pi. For the curve y equals to fx, x, the parametric equations will be x equals to t and y equals to ft. And for the x equals to gx, the parametric equation x equals to gt and y equals to t. And lastly, for the line segment, from x node, y node, z node to x1, y1, z1, the parametric equations, either we can do rt equals to 1 minus t multiply with x node, y node, z node plus t, x1, y1, t1. Or we can write as x equals to 1 minus t x node plus t x1, y equals to 1 minus t y node plus t y1, and z equals to 1 minus t z node plus t z1 for the t ranging from 0 to 1. Suppose that f equals to pi plus qj plus rk is a continuous force field. So the work done by this force in moving a particle along a smooth curve c is w equals to integrate f multiply with dr, or integrate p dx plus q dy plus r dz.
Question 1. Evaluate integrate for yx minus x ds, where c is the upper half of the circle centered at the origin of radius 3 in the counterclockwise direction as in figure 2. Question 1. Here are the steps to solve the line integral for manual calculation. Step 1. Identify function xy or function xyz. This question uses a function with two variables, function xy equal to 4yx minus x. Step 2. Determine the parametric equation. Because the question is circle and counterclockwise direction, the parametric equation for x is r cos t and y is r sin t. Then I substitute r into 3 in the parametric equation. So the new parametric equation are x equal to 3 cos t, y equal to 3 sin t, and the range for the t is between 0 to pi because it was an upper half circle. Step 3. Calculate ds. The parametric vector equation is 3 cos t and 3 sin t. Then I differentiate the parametric vector equation and get negative 3 sin t and 3 cos t. The formula to calculate ds is magnitude of r prime t dt. So the answer of ds is 3 dt. Step 4. Calculate the integral. The integral to evaluate is integration of 4yx minus x ds. Substituting the parametric equation, x equal to 3 cos t, y equal to 3 sin t, and ds equal to 3 dt. Then I get the integration from 0 to pi, multiply with 3 sin t, 3 cos t, minus 3 cos t, and multiply with 3 dt. I solve it and the final answer is 0. Here are the steps to solve the line integral for mapper calculation. I start with common restart with vector calculus and with plot. Then I insert common plot 3 cos t, 3 sin t, t equal to 0 to pi, scaling constraint, color blue, label xy, and title upper half of the circle. And this is the output upper half of the circle that I get. Then I insert the equation function common. Function xy equal to 4yx minus x. And the output that I get is fxy equal to 4yx minus x. I insert the parametric equation common. X equal 3 cos t, y equal 3 sin t, and I get the output for x is 3 cos t and y is 3 sin t. To calculate ds, I insert common dx different of xt and dy equal different of yt, and the output for dx is negative 3 sin t and for dy is 3 cos t. And I insert the common ds is equal square root of dx squared plus dy squared, and the output for ds is 3 square root of sin t squared plus cos t squared. To solve the integral, I insert the common integrate 4xy minus x ds, and the output is integrate equal to 3 multiply with 36 sin t cos t minus 3 cos t multiply with square root of sin t squared plus cos t squared. And I insert integrate equal to simplify integrate, and the output is integrate 9 cos t multiply with 12 sin t minus 1. And for the result, I insert the common int integrate t equal to 0 to pi, and the output is 0.
Assalamualaikum and hi. And now I will explain about the question 2. If the force field Fxy equals to 2xy and the kite follows the path r of t equals to cos t sin t for t in the interval 0 till pi over 2, calculate the work done by the current along this path. Next, for manual calculation, the first step is we need to compute FRT by substituting RT equals to cos t sin t into function FT equals to 2xy, so that we can get the answer which is 2 cos t sin t. Next, for step 2, we need to compute R prime t by differentiate the function R, so that we can get the answer is negative sin t cos t. For step 3, we need to compute the dot product of FRT and R prime t, and the answer is negative cos t sin t. And the last step is we need to evaluate the line integral by using the equation work done equals to integral with the lower limit FDR, and the final answer is negative 1 over 2. Lastly, I will explain about the mapper calculation for question 2. This is the plotted graph for question 2 that using mapper software. The first step is we need to call restart command, then with vector calculus and with plot command, so that we can use mathematical symbol and plot the graph easily. Then we need to state x equals to cos t and y equals to sin t, so that we can insert into R. Next, we need to insert x and y into R and differentiate it by using diff command, and the output will be negative sin t plus cos t. Next, we need to call function f equals to 2xy to get the output 2 cos t plus sin t. Also, we need to let u equals to dot product fdr, so the output will be negative cos t sin t. Lastly, we need to evaluate the integral with the limit of 0 until pi over 2 udr, and the final output will be negative 1 over 2. That's all from us. Thank you.